Okay, this is the next quick 5-minute video, hopefully, that helps you to assess whether or not you can do some pretty straightforward, we hope, calculations using vectors. And so this one basically is going to be this problem, which you're going to see over and over and over again over time. Are you capable of not only doing this calculation, but doing the notation as well? Are you capable of saying that this is span L, distance is distance A, if that is in fact right, and that of course would be B, and B is equal to, this is B, and B of course equals L minus A, and A of course equals L minus B. Are you capable, if you say that this is F, of actually writing this in a column format? Reaction here and here, and reaction there in the y direction, and saying that yes, the reaction at A to this force is equal to F times the distance from the other support, which is B over L, and going across and saying the reaction at B to force F is the distance from the other support, which is A over L. And if you basically do that with one force and another force, this time of course this is A sub 2. So summing down the thing, F2 times basically what? L minus A sub 2 all over L, and then of course F sub 2 times A sub 2 over L. Adding these up and adding these up, and then finally looking and saying, do the sum of the forces in the y equals 0? If you are not capable or set to do that, please make comments on this video. I'm going to do the next one, which these are based a little bit on some of this exam work we've seen. If you are not capable or you are not confident in doing this problem, where now you have an overhang, sorry, they will make that an overhang, and we put this as A, and this is B, and this is up and over, reaction here, right? And once again we put a force out here, F. And F is a distance of A from there, and it is a distance B from there, but this time L plus B equals A. But we can still go with the same mathematics of saying we're going to take F times the distance from the other support divided by the distance between the supports, and then put F here, we'll call this F1, times the distance from the other support divided by the distance between the supports, and realize that these two here must add to 1, so most likely the one that's opposite the cantilever is going to have a negative in front of it. So if you are not confident in doing that, please make a comment on this video, and everyone's going to be required to comment on the video anyway. So that's the second problem, or form of problem. And these are just literally solving for reactions. And there are all kinds of different ways to do that, but you do want to be able to do this as well. If you are not confident, and this is going to be a little bit different than the way most of you solve that exam, if this is a frame, and there is a force here, if you are not confident in using CAD to say that F1 times the distance here, which is the moment arm distance, equals the reaction at B times the span, please make a comment on the video. Even if you're confident or not, mark this up. You need to be able to say that force times orthogonal distance equals force times orthogonal distance, and you need to do it be able to do it consistently and relatively quickly. That is the third form. And of course the one that we put on the exam, and people spent a fair bit of time going through it, right? When in effect you do need to get confident eventually in terms of scaling things. And here is that question. If you are not capable, confident, you can't do this repeatable. If I have a frame here and I have a force here, if you are not confident in doing a slide, divide, and then measuring this distance A and this distance B, so that you can take basically the F and the Y direction, F and the Y, and say distance from the other support B divided by the distance between the supports L on this side, and then F sub Y times the distance from the other support A divided by L. If you are not confident in doing the slide divide, measure the arms, and then putting the format so you stack things up, which makes it easier on your eye and everyone else's eye, knowing that in fact these two numbers have to add up to 1, or essentially these multiplied numbers have to equal up to the forces. Once again, you need to use the check that sum of the forces in the y equals 0, and in a problem like that, of course, all of this has to be reacted to in the opposite direction over here. So those are the series of basic lever problems that we see just in terms of purely doing reactions. And if you are still stumbling on those just for doing reactions, you'll have a harder and harder time as we go into trying to simplify loadings on structures. Thanks for listening.